In this question, you have to find the greatest integer less than or equal to the value of this definite integral. Before I do this question, if you are clear about the concept of inverse function, then you must be knowing that if f alpha is equal to beta and g beta is equal to alpha for all values of alpha and beta in their corresponding domain, then we say f and g are inverse function of each other. Note that for f and g to be called as inverse function, both these things must be true for all values of alpha and beta in their respective domain. But suppose a and b are two real numbers such that f a is equal to b and gb equal to a, then immediately it should arise in our mind that f and g may be inverse function of each other, and whether they are inverse function of each other, we know the procedure of finding the inverse function. I'm not going in the detail of that. I'm not saying a and b are any two real numbers in their domain. I just say suppose a and b are two real numbers such that fa is equal to b and gb equal to a, then immediately this thing should arise in our mind that f and g may be inverse function of each other. The reality of this, you can check it with the concepts you have studied. And you can see very easily, if I put x equal to 1 in this portion, I will get log 2 to the base 2, that is 1. And if I put x equal to 2 in this, I will get log 9 to the base 2. That is, for x equal to 1, the value of this becomes this. For x equal to 2, the value of this becomes this. Similarly, for x equal to 1 in this, I'll get 1 to the power 1 by 3, that is this. For x equal to log 9 to the base 2, it will become 8 to the power 1 by 3, that is 2. That is, I mean to say, for 1 and 2, by putting 1 and 2 in this, we are getting these numbers. And by putting 1 and log 9 to the base 2 in this, we are getting these numbers. Immediately, this thing arises in our mind that these two functions may be inverse function of each other. And if we find that really they are inverse function of each other, then there is a direct formula that a to b fx dx plus fa to fb f inverse x dx is equal to b fb minus a fa. We can prove this formula geometrically also and mathematically also, but presently I am not going the proof of this formula. I just say that if you don't know, remember it. Otherwise, when you have prepared for advanced level, this formula must be known to you. And now let us check whether these two functions are inverse function of each other or not. And you must be knowing that if I want to find the inverse function of this, I start in this way: y equal to log of x cube plus 1 to the base, and from here I will try to find the value of x in terms of y, and once I have got the value of x in terms of y, in that equation finally I will write y for x and x for y. See, to find the value of x in terms of y, very first step will be x cube plus 1 is equal to 2 to the power y. This is by definition of log. This means x equal to 2 to the power y minus 1 whole to the power 1 by 3. And now writing y for x and x for y, I get y equal to 2 to the power x minus 1 whole to the power 1 by 3. This function is inverse function of this function. Hence now we are confirmed that these two functions are inverse function of each other. And now for using that formula, any one of them can be taken as fx and other can be taken as f inverse x. There is no difference. Suppose I take this as fx, then the value of this will be equal to bfb, that is 2 log 2 cube plus 1 to the base 2 minus 1 log 1 cube plus 1 to the base 2. That is, I will get 2 log 9 to the base 2 minus 1, because log 2 to the base 2 is 1. And now the next difficulty is to find the integral part of this. That is, between which two integers this lie. It's not proper that I go on checking whether this lies between 1 and 2, or this lies between 2 and 3, or it lies between 3 and 4, using the definition of log of 8 base b equal to c, means a equal to. Using this definition, we can easily check that between which two integers it lies. But it's not proper that first I try that whether it lies between 1 and 2 or whether it lies between 2 and 3. That is just wastage of time. First I try to get some idea. It is clear that if I take 8 instead of 9, the value of this will become 2 into 3 minus 1, that is 5. That is, it is sure that the value of this is more than 5. And now we'll check that the value of this lies between 5 and 6 or 6 and 7. Now we'll check. Means it is not required to check that it lies between 4 and 5 or 3 and 4. We start from it lies between 5 and 6 or 6 and 7. We start in this way. It is more than 5, obvious. And now it is less than 6 or more than 6. This we have to check. See, 2 log 9 to the base 2 minus 1 and 6. We have to check which one is bigger. That is, we have to check 2 log 9 to the base 2 and 7. That is, we have to check these two, which one is bigger. That is, we have to check log 9 to the base 2 and 7 by 2, which is bigger. That is, we will be checking 9 and 2 to the power 7 by 2 using the definition of log. If I take log in both with base 2, I will reach here. If this is bigger than this, then this will also be bigger than this. And now we have to check which one of these two are bigger. And I now square both. It becomes 81 and it is 2 to the power 7. Now let us check out of these two which one is bigger. We know that 2 to the power 7 is 128. That is, this is bigger than this. 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 That is, the value of this lies between 5 and 6. Hence, the integral part of this will become 5. Or we can check in this way also, that it is equal to log of 81 to the base 2 minus log of 2 to the base 2, that is equal to log of 81 by 2 to the base 2. And to find the integral part of this, find a number in the form of 2 to the power n which is more than this and which is less than this. It is clear that 81 by 2 is equal to 40.5. Therefore, it clearly lies between 2 to the power 5 and 2 to the power 6. And because it is more than 2 to the power 5, hence the value of this will be more than 5. And because it is less than 2 to the power 6, hence the value of this will be less than 6. That is the value of this will be lying between 5 and 6.